You flip a coin 20 times and get heads 3 times. So the chance of getting heads is 3 out of 20. Is this an example of theoretical or experimental probability? So you've got theoretical, which is all based on theory, or based on the total number of possible outcomes. So if you flip a coin, you have only 2 outcomes. You've got heads or tails. So if you flip the coin, you would have a 1 out of 2 chance every time of getting heads. Okay, but if you are looking at experimental probability, that's based on real life, based on what actually happens, okay, or based on experiments. Remember, experimental, based on experiments or real life. So if you flip a coin and you get heads 3 out of 20 times, that's not theoretical because it is what actually happened. So this would be experimental probability. You have made 7 out of 10 of your last free throws. How many free throws can you expect to make if you shoot 100 free throws? So you've got 7 out of 10, and you want to know how many that would be out of 100. Anytime I say out of, that's usually that division sign. So 7 out of 10 equals how many out of 100. So there's 2 ways to go about this. You could cross multiply 7 times 100 and then do 10 times x and simplify. 7 times 100 is 700. 10 times x is 10x. And then we need to get the x isolated. So if 10 is multiplying by x, we need to do the inverse operation and divide by 10. Over here, 10 divided by 10 simplifies to 1, and you're just left with that 1x. And 700 divided by 10 gives you 70. So that would tell me that this is 70 free throws. Okay, so that is one way to do it. You could also say, what times 10 gives me 100? Well, I know that 10 times 10 gives me 100. So if I multiply the bottom by 10, I want to keep this proportional, so I'll multiply the top by 10. 7 times 10 gives me 70. And so you still get that 70 free throws. What is the probability that a month picked at random will have exactly 30 days? So I'm going to write my months over here. January, February, March, April, May, June, July, August, September, October, November, December. Well, if I go through and write how many days they have, I know January has 31, February has 28, March has 31, April has 30, May has 31, June has 30, July has 31, August has 31, September has 30, October has 31, November has 30, and December has 31. That's the hardest part of this whole thing, is just writing those out. So, after we get those written out, we're going to say, okay, I know there's 12 total months. So that's on the bottom of my probability. So it's something out of 12. So I need to find the ones that have exactly 30 days. So 1, 2, 3, 4. So 4 of these have exactly 30 days. So I see my fraction is 4 over 12, or the probability is 4 out of 12. And I can simplify because I can divide the top and the bottom by a common factor, which is 4. So if I divide 4 by 4, I get 1. And if I divide 12 by 4, I get 3. So that probability is 1 out of 3. It's still 4 out of 12, but simplified is 1 out of every 3 months has exactly 30 days. If you rolled a number cube 10 times, how many times would you expect to get an even number? So on a number cube, you have 1, 2, 3, 4, 5, and 6. The even numbers are 2, 4, and 6. So that's 3 out of 6 chances to get an even number. Okay, if I simplify that, I can divide both the top and the bottom by that greatest common factor, which is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So 1 out of 2 chances of getting an even number. So now I need to say, okay, well, I'm rolling that number cube 10 times. So if I've got a 1 out of 2 chance of getting an even number, all I have to do is take that 1/2 and multiply it by 10. Remember, that's the same as 10 over 1 because any whole number is always over 1. And I can multiply across. 1 times 10 is 10. 2 times 1 is 2. And then simplify. 10 divided by 2 is 5. So I would expect to get an even number 5 out of those 10 times. Okay, you could have also written it as 1/2 equals how many, or x if you wanted to, or question mark, out of 10. You could have said, okay, I needed to multiply by 5 here, multiply by 5 there, and you do get 5. Or you could have cross multiplied. 1 times 10 is 10 equals 2 times question mark, and you would end up dividing by 2. So there's several ways that you can do this to get that exact same answer. A bag holds 5 yellow, 2 green, and 1 red marble. Okay, if you were to draw a marble from the bag 160 times and replace it after each draw, how many yellow marbles would you expect to draw? Now, this is expect. It's not based on the experiment. It's based on theoretical because it hasn't actually been done. So we're going to see how many total marbles there are. So there are 5 yellow, 2 green, and 1 red. 5 plus 2 is 7, plus 1 is 8. So there are 8 total marbles. 5 of them are yellow out of 8 total. So if we draw a marble 160 times, how many yellow would we expect to draw? So I've shown you several different ways on previous problems of how to do this. You can cross multiply. 5 times 160 equals 8 times x. And then divide both sides by 8. So you're left with x equals 100. Or you could say, what times 8 equals 160? And I know that 20 equals 160, so I multiply the top as well, and that would also give me 100. You could also do 5/8 times 160, and you would still end up with 800. Remember, this is always over 1 over 8, and that still gives you 100. So out of 160 times of drawing, you should expect to get yellow 100 of those times. Okay, a bag has 7 green marbles, 2 red marbles, 3 yellow marbles, and 5 purple marbles. What is the probability of choosing a purple marble? So the first thing to do is find out how many total marbles you have. So you've got 7, 2, 3, and 5. So 7 plus 2 is 9, plus 3, 10, 11, 12, plus 5 is 17. So there are 17 total marbles. And then I count how many purple marbles there are, and there are 5. So the probability is the purple over the total. So 5 out of 17. And you could write it like that, or you could write it like this. If you select a croquet ball and then do not replace it, then you select another one. Is this an example of independent or a dependent event? Well, an independent does not rely on anything else or on another event. Okay, think about if you are an independent adult, you are not reliant on your parents or a caregiver of any sort. If you are dependent, you rely on others. So you depend on others for anything. Okay, so rely on another event. Okay, so let's look at this. If you do not replace the croquet ball, so let's pretend there were 10 croquet balls to begin with, and you selected one out. Now there's only 9. Okay, so that does tell me that this is a dependent event because you're not going to have the same probability that you would the first time because it depended on if you replaced. Okay, there are 5 different cookies in a bag. 2 of them are your favorite, sugar and peanut butter. What is the probability that you will not get your favorite? So if 2 kinds of those cookies in that bag are your favorite, and there are 5 different cookies in there, what is the probability that you will not get your favorite? So this is that you will get it. So how many of those kinds are not your favorite? Well, if 2 are your favorite, there are 3 left in that bag that are not your favorite out of 5 total. So 3 out of 5 is you will not get your favorite. A basket contains 7 green lollipops, 12 red lollipops, 7 orange lollipops. When a lollipop is taken from the basket, it is not replaced. What is the probability of getting a green first and then red? So the first thing we have to do is find out how many total lollipops. So 5 plus 12 plus 7. So 5 plus 12 is 17, plus 7 is 24. So the first time I have 24 total lollipops, and I want to know about green. So I have 5 green lollipops. So 5 out of 24 of those is my probability of getting green the first time. Then I've got to find the probability of getting red the second. So the second time, there's not 24 lollipops anymore because I took one out. So now there's 23 lollipops, but there are still red because we're assuming I got green the first time. So 12 out of 23. Now those are two different probabilities, but we want to know the total probability, so I have to multiply those two together. So just like when you multiply fractions, you multiply across the top and then you multiply across the bottom. So when I multiply across the top, I've got 5 times 12. I get 60. Then I multiply across the bottom, 24 times 23, and I do get 552. Now, I know these are both divisible by 12. So I can divide both by 12 here. And I get 60 divided by 12 gives me 5. 552 divided by 12 gives me 46. Now, if you ask, how did you know, Miss Sebastian, that that was divisible by 12? Well, I looked at my initial problem, and you can cross-simplify 12 and 24. 12 can go into 24 2 times. So I can divide both of those and then multiply across. 5 times 1 is this 5 over here. 2 times 23 gave me 46. So the probability of getting a green and then a red is that 5 out of 46 chance. The letters in the word pizza are written on slips of paper and placed in a bag. Each letter will then be put back after it is drawn. So what is the probability of getting a Z and then a vowel? So there is 1, 2, 3, 4, 5 letters in the word pizza. 2 of those are Z's. So to get a Z first, I would have a 2 out of 5 chance. Then the letter is returned the second time, so there are still 5 letters. And I want to know about a vowel. A vowel, there is A, E, I, O, and U. So I see A and I up there. So I've got a 2 out of 5 chance of getting a vowel. So if I want to know the probability of getting a Z first and then a vowel, I have to multiply those two. So 2 times 2 gives me 4, and 5 times 5 gives me 25. So I have a 4 out of 25 chance to get a Z and then a vowel.